three big drivers of our portfolio currently are full self-driving cars, in vivo therapeutics through CRISPR, and allogenic cell therapies. Those are the three big drivers. I'm going to explain why, and I'm going to also talk a little bit about why we think those are the big wealth-generating drivers in the near future. This is the Not Even Wrong podcast. It's August 1st, 2021. This is Cryptelco. It's a Sunday, so there's no update. We are still up 2% for the year. The market's 17.5% up. We're underperforming by 15.5%. I want to push out this episode just to sort of set the stage for the next couple of quarters, because I think they're going to be crucial in terms of wealth generation. We expect to get back to our highs and even reach higher than our highs in terms of the portfolio returns, since we believe that those three drivers are going to show a lot more promise in as I said, in the maybe next 2, 3 to 4 quarters. The three drivers are self-driving. I said full self-driving before. Let's just call it self-driving and not get entangled about is it full or not. The fact of self-driving is driven by the ability of a robot to use computer vision to control its own actions, and it's going to be manifested in the self-driving of a car, and we believe that Tesla is going to be the market leader in this particular space. So this is the first. The second is in vivo therapeutics. Intellia is a leader in that space. I'm going to explain why in vivo is so crucial, and also why CRISPR is very crucial, and allogenic cell therapies with or without CRISPR, and generally through genetic engineering, is a third big driver of our portfolio. Before I go there, I just want to shout out to a new service I just came across. It's called CRISPR Investors. It's a YouTube channel. The link is below. I don't know who is running it and who is behind it. Just want to shout out, very useful channel, and actually that channel gave me a very clear understanding of in vivo versus ex vivo therapeutics and how important the Intellia breakthrough is that came a couple of weeks ago. I'm going to discuss this when I discuss in vivo, ex vivo. But let's get back to the fundamental thesis here. And the fundamental thesis is the following. It takes a certain risky bet by a company, usually by a founder or by a very visionary CEO, to take a technological bet, to take a step into a technological landscape that is unproven, often almost laughed at by the peers, and then over time it takes building the innovation stack. This is one of our 4 principal books, the innovation stack by Jim McKelvey. The innovation stack is really building around that technology, and those 3 steps, those 3 drivers that I just outlined, self-driving, in vivo, and allogenic cell therapies, those that have all that flavor, that people took the risk and said, look, we're gonna build a technology stack on something which is unproven right now, but we're gonna build that innovation stack around that, and we're gonna start becoming valuable and eventually dominate the market. So let's start with the first one, image recognition, computer vision as the basis for robotics. This is the key decision that Elon Musk made sort of in the 2016 period. He saw the results of ImageNet, which came out in 2012, and then of course more refinements and all that. He saw the results that came out of computer vision labs such as Fei-Fei Li's lab at Stanford, and where Andrej Karpathy was working, and he went full in on the decision to use computer vision as a basis for self-driving cars. I believe that him working with and now the name eludes me, there is this young kid that hacked an Apple iPhone, and he became famous. He worked for Elon Musk for a while. I think his name is Andrew something. The name eludes me, but the point here is he worked with that gentleman, and he actually said in a conference I attended that he believes that the DARPA challenge people were kind of stuck in their technology using sensor fusion because they didn't have the ImageNet results. They didn't have the ImageNet breakthrough. Once the ImageNet breakthrough came, you should have thrown away all this technology and just bet on vision. Now, I don't know if that came from him and Elon got inspired, or he got inspired by Elon. Doesn't matter. Elon made that decision in 15, 16. Tesla bet on full computer vision, and the reason full computer vision is so important is first and foremost, it's scalable, it's low cost, and it has the potential to deliver results. People like Waymo are still claiming that that's not possible. You need all the other stuff, LiDAR and all that. We believe that that is not necessary, that you can build a self-driving car with computer vision only, and this is the trajectory that Tesla is on, and that's why we believe that wealth generation at Tesla is still going to continue at a strong pace. The second driver is in vivo cell therapeutics. This is where I got inspiration from that channel that I said, CRISPR Investing. Again, the link is below, because the person there explained in very clear and concise words what the difference is between in vivo and ex vivo, and why the Intellia breakthrough is such a big deal. Now, here's what happened. First of all, what is in vivo? What is ex vivo? So in vivo is, imagine you have a CRISPR technology. Imagine you want to do a gene editing process to solve for something. Let's say you have a liver disease. You want to, and the liver disease is driven by a monogenetic disease. So there's one gene that is maybe wrong in the specific part of the genome, and you want to change that, you want to edit that using CRISPR. You can do this in two ways. In vivo would be you inject the CRISPR technology into the cell of the living person, and it gets edited, and then we go from there. Or you do it ex vivo, you take a certain tissue out of the person, you do it ex vivo, you inject everything there, you let it grow, and then you reimplant it to the person, and you hope that the healthy thing will grow and the unhealthy will be replaced. So these are the two sort of approaches, in vivo versus ex vivo. Intellia in July published a paper where they showed tremendous success with an in vivo technology. What does in vivo actually mean? First and foremost, you need to have the CRISPR tech, but you also have to have the delivery. And this is where in vivo is so critical right now, or why it's a big problem, because we still don't know how to deliver in vivo technology into living beings, in particular the humans, without, of course, side effects and off target and all that stuff. So Intellia had success. We believe that this is the beginning of a massive evolution in therapeutics from ex vivo to in vivo. And also, because we are working with CRISPR here, there's sort of a compound of effects. Number one is the CRISPR technology per se, which has huge positive effects on therapeutics. And number two, the fact that it's in vivo is going to lower cost, increase scalability, and also the innovation stack that Intellia is building around in vivo. Of course, it's just the beginning. We believe that in 5 to 10 years, Intellia easily could be the largest pharmaceutical company in the world, because they're building an innovation stack around CRISPR and in vivo, which is amazing. The third driver is allogenic cell engineering. This is a company we're going to invest tomorrow, actually. Caribou just went public, is a leader in that space, using CRISPR technology with a new approach towards cell engineering. We also have another component in our portfolio, Fate Therapeutics, which is also using gene engineering for allogenic cell therapy. In general, allogenic cell therapy is that you take, now here it's all ex vivo, in a sense that we do something outside of the human body. We engineer cells, and then we re-inject them into the human body. The people, Fate Therapeutics and also Caribou, are working on cancer immunotherapy. So what they're doing is they're building cells outside of the human body that can fight cancer tumors and then inject them into humans. This is immunotherapies through cell engineering. You can engineer CAR T cells or NK cells. Both of them are used to fight tumors. And what's so promising about the cell therapy in general is that it's working, first and foremost, and that it's also an immunotherapy, so you can use your own immune system, which is adaptive, which has memory, which has certain intrinsic value relative to, let's say, other drugs that don't have that. So it's kind of more of an adaptive, natural system to fight cancer. What's really amazing about allogenic versus the other approach, which would be autologous. So that means, okay, allogenic is you take off-the-shelf cells from healthy donors, third-party donors, you reprogram them and you inject them into the patient. You need to solve three big problems here. First and foremost, the cell has to go and find the tumor and kill the tumor. But most importantly, you also have to make sure that the immune response of the patient doesn't kill that particular cell that you're injecting. So these are the problems that need to be solved in allogenic cell therapy. The advantages of allogenic cell therapy versus the other therapy, which is autologous cell therapy, would be autologous is that you take cells out of the patient and then you re-engineer them and then you put them back in the patient. The problem with that is it's costly, it takes time, and very often the people that are sick, let's say elderly, or people that already have diseases like AIDS or whatever, they could have a weakened immune system already. So taking their immune cells and then re-engineering them, putting them back, could not really have that much promise. So allogenic cell therapy is one of those 10x better, 10x cheaper, if not even more than one order of magnitude on both sides of this equation. So we at Orange Capital Partners, our mission is to invest in technology, to generate wealth by investing in fundamentally new concepts and engineering practices with large impact. Those are fundamentally new concepts. So again, computer vision for robotics, in vivo therapeutics through CRISPR, and allogenic cell therapy through CRISPR or other gene engineering technologies. Those are new concepts, new engineering practices with large impact. So they fit perfectly well into our mission. And like I said many times before, for us at Orange Capital Partners, the main margin of safety that we have here when it comes to investing is actually when we're aligned with our mission. As long as we're aligned with our mission, we believe we have the chance to generate the kinds of returns that we set out to achieve. And we believe the reason for that is not that we're right or wrong or any of that. It's just that our mission comes from us. It's who we are. It's what we want to achieve. So if we can find entrepreneurs and founders and companies that share that mission, that share that vision and value system, we believe we have a good chance to help them by providing the capital and sometimes also other knowledge and just conversations with them, help them get to their goals, and by that, if they achieve their goals, they also help us achieve our mission. So this is where sort of a win-win for us and for them, and we believe that this is very important. I've spoken about this in one of the previous episodes. There are lots of good companies out there, companies that have potential to generate wealth, but they're not aligned with our mission. And if they're not aligned with our mission, doesn't mean they're bad investment. It's just not good for us. For us, works is this, again, to come back, what really works for us is that you take a big bet on a certain concept, and then you build engineering practices around that concept, what we call an innovation stack, and then you have the large impact. And if it's something that we also have an affinity to, like biotech or energy and robotics, which is Tesla or our CRISPR companies, then we believe we have a good chance to succeed. Thank you.